Ladies and gentlemen, welcome back again to our Siemens and Guests studio. My name is Christine Brunner and I'm joined again by Andrew Whitetalk to be your hosts.
Hello everybody. Let's today dive a little bit deeper into the chemical industry. Environmental impact is definitely one of the major challenges in this industry.
But where there are challenges, there are opportunities. The industry is experiencing digital and ecological transformation. Innovative technologies, process optimization, and advanced handling of energy and resources point the way to the future.
In this session, we will see how customers BASF and Plastic Energy are looking to solve these challenges with the latest technology.
And as much as I love our little studio, I wanted to see the big wide world of the chemical industry.
So, Christine, you've been out and about then?
Yes, I visited BASF, learn about the future of the digital twin, or actually about the fact that the digital twin has long since arrived in the present of the chemical industry. So let's take a look at the video. Welcome today from Ludwigshafen. I'm here at the BASF headquarters, which is literally a city within the city, and it accounts as the world's largest integrated chemical complex. 1/3 of BASF employees worldwide work here, which accounts to a number of 39,000 employees. And one thing at BASF they don't do, stand still. They're constantly improving and developing new processes and products. Their claim definitely comes alive here. We create chemistry for a sustainable future. And for sure, digitalization plays a major role, if not the major role, in the chemical industry. With me is a senior engineering manager at BASF, and he will unveil some secrets now about the use and work with the digital twin. Welcome, Matthias Roth.
Welcome to Ludwigshafen, Christina.
Thank you for having me. It's really an impressive site, and already 15 kilometers before Ludwigshafen, it started to see the BASF signs. So very, very impressive, and I'm really curious now to get some more insights from you. Well, in the daily work of engineers in the chemical industry, we see how important digital planning and modeling tools are for the efficient operations of plants. In practice today, there are often optimized but isolated solutions. And whenever it comes to interfaces between these islands and tools, a lot of untapped potential is seen. How have you at BASF been dealing with this?
Yes, we have also seen this untapped potential, and this motivated us to go for an innovation project together with our partner Siemens. We wanted to know which kind of potential we can already address today with existing state-of-the-art tools. We wanted to learn which kind of interfaces are missing, where we need to automate existing interfaces. And in general, we were interested in coming up with a framework for digitally integrated tools for plant operation.
Mm-hmm. So tell me about this potential behind the digital twin based on your project then.
Well, first of all, digital twin can mean a lot of things. We concentrated us a little bit on automation aspects. So the title of our innovation project was Digital Twin of Process Behavior. And our main motivation was that we see the need to adapt our plants constantly to changing ambient conditions. We need to optimize the plants and doing changes. This needs to be done in an efficient way, and there digital tools can be very helpful. Another important aspect is that a digital twin can reduce the gap between what we have in a plant as kind of implemented solution and what we find in the planning data.
Mm-hmm. And why is this so important?
Well, imagine you're an optimization engineer busy with a study in a plant. Your goal is to improve yields or energy efficiency, and you're analyzing historical data of this plant. You see that at certain times the plant is showing oscillations or other problematic behavior, and then you want to know what's the reason for that. Could be changed ambient conditions, could be changes in raw materials, but could also be changes in equipment, could also be changes in parameters that are implemented in the automation system. And so you need access to all this information to do a good study. And this is not always easy today.
So your aim was to explore the capabilities of a digital twin in an innovation project. What do you think are the prerequisites to bring the digital twin already today into the chemical industry?
Well, the key is availability of data, structured data, and the availability of models. And I'm convinced that we have to invest a little bit more upfront in the engineering phase of our plants, because at this time it's rather easy to create all this data, to create all those models, which can be very, very helpful when it comes later during the plant life cycle to optimization tasks. So we need the kind of mindset that we say we don't only engineer a plant until the startup, or that's the only goal, to have a successful startup, but we really need to make the plant and all the planning data around the plant ready for a later optimization in the plant life cycle.
So what about the trends of modularization and digital twins? How do these two interact?
Yeah, that's a good point. I see here the challenge of unit operation. Today, as you have also mentioned in your introduction, we see a lot of different silos of automation systems. Maybe you have a very large chemical complex where you have one central control system in place, a DCS, but then you also have dedicated controllers for a compressor unit and for a combustion unit, let's say. Now imagine you are again this optimization engineer and you're again busy with optimizing the plant, and you see some problems in the behavior of a compressor. And then of course you need to access the controller of this compressor.
I hear a lot of control and optimizing. What are typical challenges?
Well, one of the challenges is when you want to access, for example, a controller of a compressor, you need to find the right engineering software. Then you need to find the right parameters. You need somebody typically to help you to understand what is really implemented, what do the different parameters mean. Then you come up with an optimization idea. You say, okay, here and there we need to change one or two parameters. You implement those changes, and then you also want to be sure that those changes are persistent. You don't want to have the next maintenance engineer entering the plant, connecting his laptop to the controller and just overwriting everything you've done. And these are the challenges today.
But can't it be managed without a digital twin anymore?
It can be managed. It's managed today, I would say. We are doing a lot of optimization projects also successfully, but typically we have to counteract on these challenges with a lot of organizational measures. So we have to, for example, say that we need a backup PLC to perform tests. We need to be very clear where in the net drive we store all the engineering software. We need to involve a lot of different people to work on all those problems and challenges. And of course, this kind of organizational problem, let's say organizational solutions to these problems, tend to be not perfect and tend to be inefficient.
I mean, of course, a lot data, a lot more activities, a lot more which can be tracked and controlled. So definitely help of a digital twin is nice to have. Speaking about the future, where does a digital twin, in your opinion, reach its limits?
Well, today we have, let's say, digital twins of different parts of the, let's say, plant operation, let's say of the automation system, for example. But I think we need a full picture of what is really implemented in the plant. So it starts at the DCS level, equipment level, going down to all the units, as we discussed before, like to the compressor controller, and then really down to the field where we have the sensors and the actuators installed. I mean, you have digital devices everywhere nowadays. And of course, you can change parameters everywhere. But sometimes it's not very easy to know which kind of parameters did we have in the flow measurement, for example. And this kind of information needs to be available in the future digital twin, covering all this, let's say, digital devices and so on.
So where would you see the highlights of this project?
Well, I think the highlights were really where we worked together with Siemens and all the involved partners. We had a joint development. Very early in the project, we already saw that Siemens is really willing to listened to us, and it was really just a joint approach, and this was really nice.
It's nice to hear that my colleagues are listening to you and then develop some solution together and not just jump in here and bring you something which you have to work with. But it was a joint effort and joint solutions. That's really great to hear and great to see. Well, ladies and gentlemen, you see, we do talk to our customers and we develop projects and solutions together. For me, it's nice to see what we could do with and for BASF. And if you're interested in learning how the taste comes into your toothpaste, or why your running shoes are so super light and still stable, or why your sofa is so super soft, then you should not miss your chance to visit the BASF Visitor Center in Ludwigshafen. It's really great coming here and taking that chance as well. Well, thank you, Matthias. It was great getting all the information about the digital twin. No digital twin, though, in the Visitor Center. But I'm sure there will be more interesting projects on the road, and I'm curious to see what's coming next. All the best to you.
Thank you, Christina. Thanks.
And now, back to the studio.
Interesting to see how BASF is and will be shaping their future with digitalization. Looks like you had lots of fun, Christine.
Definitely. It was truly an unforgettable experience getting that glimpse into the future. And talking about future, when it comes to sustainability, it's clear that digitalization and the digital twin can play an essential role.
Each year, Europeans generate 25 million tonnes of plastic waste, but less than 30% is collected for recycling. Globally, plastics account for 85% of waste on beaches. Plastics end up even in the lungs and on the plates of all of us. The impact of microplastics in air, water and food on our health remains largely unexplored.
Wow, you did some research, and I have to say, impressive and frightening facts that you put on my plate here. Another highlight of today's session is the talk we recorded a few days ago with Carlos Monreal, the founder and CEO of Plastic Energy, a technology leader in chemical recycling, and Eckhard Eberle, our CEO for process automation within Siemens.
Yes, let's watch that video.
From water to land to air and even up in outer space, there is hardly a spot that is untouched by plastic. The invention of this durable and versatile material has proven to be both a blessing and a curse. With a life cycle of less than 12 minutes, the plastics that we use and throw away are rarely recycled, and then they are piling up in landfills or in our oceans and rivers forever. It is estimated that our oceans hold more than 150 million tons of plastic, and if we continue in this direction, by 2050, there will be more plastic than fish in the sea, and the situation on land will further worsen. But there is hope, and we will share the good news in our upcoming talk with Carlos Monreal and Eckhard Eberle. Gentlemen, thank you that you're joining us.
Thank you for inviting and letting us participate.
Very, very pleased to be here today, and very much appreciate the opportunity to have this conversation.
Eckhard, let me start with you. Can you share some insights on the importance of sustainability and how recycling is connected to it?
Yeah, sustainability is absolutely must. At the moment, or in the meantime, it's not a nice to have anymore. It's an integral part of our business, and it's something which is accelerating even more now at the moment. And there are various factors behind which are addressing this. And this is the one what you said already. I mean, we only have one world, and we have to live with it. This means climate change is going on, and we have to stop and do our utmost best to improve the situation. And I think this is something where everybody has to complete. A second part, what I think is getting more important also, is that it's getting somehow more attractive within industrial business to cope with that, because even international financing communities are starting thinking about which company is really paying into sustainability. So this means money is getting more expensive if you do not work on sustainability. So this is a driver very much also to invest in sustainable factories and sustainable places, and also addresses topics like a circular industry. And the third one, for sure, innovative technologies. I mean, we are directly on the way to establish stuff, particularly a lot of processes are getting involved where we can help with our systems. And I think this is something exciting. And it goes also into the business cases. What I hear from quite some customers, although maybe the CO2 part is not that active yet, but they start calculating their business cases with an internal CO2 price in order to make sure that they are already today coping with that, what they will do in the future. And so this whole thing, including that what is resource transformation, is going to be a big thing in the future. And for sure, bringing that back into the industry which has been released in produced goods is something which is a big thing in the future, and this is circular industry and recycling. So when we are looking on this, we have four major ways to do so. I think the very much what everybody knows, bringing glass bottles back and having a reuse of this in this industry is something which is a very normal thing. The next stage, what we see is that we have mechanical recycling, like PET bottles, which are going to be compressed, and on a normal process, mechanical process, will be refurbished into other materials, which is something which is very known at the moment and used. There's for sure something which is very common. This is thermal recycling. So this means we are burning the plastic and getting energy out of that. Maybe this is not the smartest way to do, because I think we put a lot of energy in to create the material, and now we are burning it. So I think this is maybe not the most effective one, but at the moment it has been up to now a very common part. And for sure, which is a very exciting part, because it's also technology-wise interesting, is chemical recycling. So we are bringing back the material into to their original substances, more or less. And I think there's somebody who can talk far more about that than me, and this is Carlos Monreal. Carlos, you are the founder and CEO of Plastic Energy. So why don't you explain a little bit about that, what you are doing with Plastic Energy?
Thank you very much. There is a rising need for chemical recycling and really using the used plastics as a feedstock. Only in Europe, just following in your example, we are currently sending to landfill and incineration something more than 20 million tons of plastics every single year. And if we want to compare this with what we are recycling today, it's something in the range of about 5 to 6 million tons of plastics yearly. So clearly, this is something we need to change. Doesn't make any sense to produce such a valuable product and then, in the other hand, to burn it or to take it to the landfill. So Plastic Energy Vision is a process developer for chemical recycling of plastics, is to support the circular economy of plastics, what we call plastics to plastics. Not plastics to fuel, but plastics to plastics, by diverting plastic waste away from landfill and our oceans with our unique and patented technology, while we help to decarbonize the whole industry. And in the case, for example, of the incineration industry, to try to divert plastics that are being burned today, that are potentially one of the biggest components to create the CO2 emissions that we all want to avoid.
It all sounds very easy, Carlos, but I think it for sure was not as easy as the outcome of this project and process might look. So let's talk about the challenges of this process. How do you maintain the quality of the end product and the efficient process operations, and especially to ensure the environmentally friendly use of resources?
Clearly, this is like any technology, or this is you always have to face different type of challenges. And plastic waste, used as a raw material, is clearly a big challenge. And this is when trying to maintain particularly the quality of the products, produced, as well as the efficiency of the process. We have to follow very high requirements while designing, optimizing the processes and protocols for converting plastic waste back into virgin plastics that is even suitable for food-grade applications. This is what we do with our process and producing an output that we call TAC oil, which mainly it is a valuable product that replaces fossil oil naphtha that is being used today by the oil companies to produce the plastics. The aggregation of information and data throughout the entire process is essential for achieving the required quality while keeping the process efficient and economical. Therefore, using advanced strategies for plant control and maintenance, it is and also reliable instruments for information acquisition and process control is fundamental. These are areas where Siemens plays an important role in our technology.
So in regards of the entire process, for sure data is important. So let's focus on the role of the data now. Continuous analysis of data from the entire plant and modeling of this data for sure leads to a new dimension of transparency. Eckhard, how does holistically collected data help to maintain processes on an ideal performance level?
I mean, this is an absolute must in the meantime, and a very important thing, in particular in processes which are somewhat very sensible and where the quality is very important. And it addresses various areas. So one thing is looking on the quality of the product. Carlos wants to deliver perfect quality to his customers in the future then also, which is going again back as in the base material of further chemical processes. So it's very important to have a consistent quality. Second part is efficient processes. I mean, we cannot burn further energy, and waste energy in producing so. So I think it's a very important piece that we are looking on the energy consumption in a recycling process, which is very important. It needs to be environmentally friendly. And what is a very important piece, I will come to that in a second, is also the uptime of the plants, because I think this is something which is also very important. So when it comes to the recycling process itself, it's very important to keep certain parameters of the process in a very stable environment. And therefore, our control system is very important to keep the parameters to measure temperatures, flows, pressure, and look on the process of the plant and make sure that we can have a consistent process which guarantees the quality of the output in a very strong way. And this is why we are using our process control system PCS7 in helping to exactly do so, that Carlos is getting a perfect, consistent quality out of the production. And I think this is something which is very important. For sure, also a question of how to scale up, how to increase volumes, how to generate the output is something very important, as well as also the management of the devices and the field services. And this comes then also back to one piece which is very important. We talk a lot about predictive analysis. What is the background behind? We need to make sure, in particular in chemical processes, that we have a strong uptime and we do not have unforeseen shutdowns or events in a plant, because this can cause a lot of hassle and trouble to the operator of the plant, because at the end of the day, if you got stuck, it may even happen that you have to replace all the piping because material is getting stuck if you do not continuously run on the process. So it's very important to observe and looking on the status of the plant, of the equipment, of the sensors, of the pumps, of the motors, in order to make sure that you are predictive in understanding what happens, in order to make sure that something, if you know it in advance, the problem can be solved before something happens within the plant. And I think this is something where this is absolutely a must at the moment, and also the new technologies. And what is very exciting with Plastic Energy, we are working also on new solutions for the instrumentation part, which is then also something which fits very much to the challenging requirements in this industry. And we are really proud to support creating some kind of a standard in this industry with a technology as a technology partner. So I'm really looking forward to continue on this.
Perfect. Sounds very critical to kind of assure a smooth operation, that you have all the data and that you're working and you trust the data for sure. So also important is to trust your partner you're working with. And this brings me to the next chapter here in our talk, the role of partnerships. Reliable partnerships are gaining importance in our everyday business. Everywhere we hear about that there are joining forces, and we talk about ecosystems, kind of relying on others but working together. So what is the story behind the cooperation of Siemens and Plastic Energy, and how did this evolve?
Well, I think is that to me, I think it's a perfect example. The answer before that is how much knowledge a company like Siemens has developed with a partner like Plastic Energy. I think that this is really extraordinary. It's really describing our process, the challenges that we went through, to the detail that it was explained before. And clearly that is only possible if you have a good partnership and a good collaborations. We are facing a global challenge that can only be addressed through collaborations. It is not only a question about a business opportunity of investing over 30 billion euros globally over the next 10 years. We are trying to address something that the whole society needs to tackle. And a perfect example of this is really the collaboration with Siemens that it really started many years ago. The first contact was made on an exploratory basis. When we got to start to know each other, the capabilities, then that start to develop and transpire the success that we have now in building on a global partnership and the value that we bring to each other. So very pleased with this collaboration.
We love to hear this, but out of curiosity, I'm interested in Plastic Energy is relatively new. You guys exist since 10 years. Whereas Siemens is the old lady with 175 years. How does this kind of connection and partnership work with a very new and a very old partner?
Well, as an entrepreneur, I will say that this is I've been developing technologies for the last 35 years. And really the Plastic Energy, I started back in 2011. But looking and working with a company like Siemens and over 100 years of operations, of excellence of operations, that is clearly an example for companies like ours, and trying to really be as good and hopefully lasting as long or that Siemens has done so far. So very, very looking forward to that.
So do we. So let's focus on the future now and get an idea of what it might look like. The outlook now is our topic. So question to the two of you. Sustainability is pretty much the buzzword in any industry, no matter where we look. And Eckhard mentioned in the beginning that it's not something nice to have. Being sustainable is a must. So how do you see the future of your collaboration and the topic of sustainability as such? So who wants to start first?
Happy to do so. And then could give Carlos the last word then on this. First of all, I think there are two areas what we might look at as a company as Siemens. One thing is our own cleaning our own corners and places, which means sustainability for us as a company. Siemens was one of the first ones in 2015, which were announcing to have a target by 2030 to be totally CO2 carbon neutral with our factories and with our own places, with our entities. And I think this is absolutely very important. We already achieved 40% reduction since then. And I think there's a big step forward. And when we're looking, for example, on our factory in Karlsruhe, we see a lot of development in a very short time. I mean, we are taking 100% green electricity. We have 900 square meters of photovoltaic on our roofs. In the meantime, 0 tons of landfill and 99% recycled processed material what we are bringing in. And we had almost 3,000 tons of CO2 reduction. This is 75% since 2014 at our site. And at the same time, we significantly increase our production volume in the factory. For sure, a lot of other measures like LED lighting, waste heat recovery, and also efficient cooling are factors which we are driving even more. There's the other side, and this is how we can help in the industry. And I think this is even more important because we are very active in quite some industries, like in the chemical ones, which are very energy intensive. So for us, it's very important to help our customers to be more efficient, to reduce the use of feedstock, to support in processes like recycling, which are very important to contribute on this. And I think there are two factors which are bringing in. One is our domain knowledge somehow about the industry to understand how processes are looking like, and then helping our customers with a real and a digital world and representation to optimize, to simulate, and try to do the best, really to make the best output with the least material input. It's something where we are contributing heavily, and I think this is a topic which is not a buzzword anymore, but really essential for the future business. And therefore, we fully will support also Plastic Energy in the future to go with their processes and development this.
So thanks, Eckhard. That's a lot of things on your list, which we already have accomplished at Siemens and still are going to. Carlos, how important is sustainability to you and to Plastic Energy?
And sustainability is within our heart. Now, this is really something that is really we are not only thinking about increasing recycling, but for us is also promoting and helping the whole industry to decarbonize. Particularly reducing the CO2 footprint across the industry is key. However, something that we are not doing good, and this is not anything to do with the material, is that as a society, we are only recycling something like about 14% of all those materials that we are producing. And in most of the cases, that is due because the waste is not being collected. Just to put the example of the city of Jakarta in Indonesia, that has similar population than London, more than 12 million people, and however only 60% of the waste produced in the city is being collected every day. So what happens is that then the rest is dumped where we don't want this type of waste to be to go, which is the environment. So that is something that we have to change. As a company, we are going to do the best that we can in order to be able to participate in increasing the recycling quotas of plastics from 14% to as high as possible. I don't want to say that we are going to be able to do what the paper and the glass industry has done over the last 30 years within only 10 years. But clearly, we have to try to target to reach those quotas as fast as possible, and hopefully will not take the 30 years that other materials took for them to be able to have high grades of recycling quotas. However, as a company, as I was mentioning before, we are going to try to do our contribution, and we are aiming to process and recycle 5 million tons of plastics by 2030. That means that we are going to have to build several plants across the globe in order to recycle those plastics. That will mean that we will have to count with Siemens for all those different plants in order to keep the quality and the efficiency on our process, which is critical because our customers are requesting not materials or not products that have impurities. We have to be able to deliver an output that can be measured within part per billions of impurities. And that requires very precise equipment, instruments that the relationship that we are developing with Siemens will help us to be able to achieve.
We really are hoping that you will achieve these goals because that's important for all of us. And is it just that the awareness is not there, that we are not recycling, or is it the hassle of collecting and separating? What would you see is the main reason that it seems to be so hard to recycle plastic?
The main problem that we have is the collection of waste in general. We don't see plastics in Europe on the streets. That is something that it might happen after a big party, a big celebration, let's say before the waste industry is collecting the waste that we have left it in the streets. That is the responsibility of the people, really, that they have contributed to that type of waste where it doesn't have to go. But in Europe, we are living a very good situation in regards of sustainability because we are doing the good job in really properly collecting and processing those type of materials the best way that we can. Obviously, as we were saying at the beginning, that can be improved, like we always try to do in life. And this is what chemical recycling is going to try to do, to improve and divert plastics that are being burned today, and we are going to be able to give them a better life. However, the biggest challenge is really how we could be able to improve collection of waste in the developing countries where that is not happening. And that, as a result of the increasing collection, that will allow us to do what Europe has been doing over the last 30 years or 50 years. If we do the proper collection and clearly the right processes like recycling, that will just help to our environment and that will improve the sustainability of our planet.
I promise with every water bottle that I will think of you, and I hope that it ends up in one of your plants and is going to be recycled. And I am very curious to see how this partnership and joint journey of Siemens and Plastic Energy in chemical recycling will continue. So thanks to the both of you for your time and the precious insights.
Perfect.
Thank you very much.
Thank you very much.
Digitalization really accelerates sustainability. What an impressive project. Now, Andy, let's go to our news talk with our colleague from the UK to find out more.
Yes, he's already online and he was involved in the project with Plastic Energy. I'm looking forward to him giving us some more insights. Partnerships, ladies and gentlemen. We know how much support they give, and as we have just heard from Carlos and Eckhard, this is exactly what Siemens and Plastic Energy rely on. So if you've ever wondered how Siemens can help you to turn ideas into reality, this is how we do it. We see strong partnerships as a growth enabler. But as with every partnership, it's always interesting to learn how it all started and how it evolved. So let's hear the voices behind the story. On the line, I have Derek Moore, Business Manager for Measurement Intelligence in the UK with me. He worked and still works closely with Plastic Energy. Derek, when we talked a little bit earlier, you were telling me how you learned about that Plastic Energy project firsthand, or for the first time. Tell me a little bit more about that.
Yes, indeed. Plastic Energy are based in London. We, as the local Siemens team, we reached out to them on an exploratory basis. Getting to know them better, their needs, their capabilities, it quickly transpired that a global partnership generated the most value for both partners. Plastic Energy has an incredible domain know-how and was seeking a partner who could add the technology know-how that would help leverage the idea and turn it into reality, scale it.
Right. Yeah. I mean, what really stuck with me when I was looking at this and doing my research was that ambitious goal to process 30,000 tons of plastic by 2025. I mean, plastic waste and the circular economy are really serious and big topics that are affecting everybody, all countries around the globe, right?
Absolutely. Plastic Energy are modular in their approach to make sure the plants can be built virtually anywhere in the world and can be integrated into existing infrastructures. This was one of the main guiding principles when our team in the UK investigated the innovative process and offered the fitting instrumentation and automation platforms. Plastic Energy's plants needed to be flexible, yet carefully controlled while meeting high safety requirements. Our instrumentation and PCS7 as an automation platform ticked all of those boxes. Ever since then, we keep growing together.
Together. I mean, that's a great story, isn't it? Tell me more about this collaborative approach that you have with them.
The collaborative approach exists between companies, business units and countries. It's really paid off. Plastic Energy is building facilities in Europe and will scale up in the near future. By now, We help them manage their facilities on a global basis and therefore support their growth. Being the innovative company they are, they also welcome and embrace concepts such as a digital twin or the digital worker.
That's so impressive, Derek. I really, really love this story. Local and global, modular, scalable, flexible, and a real showcase for international collaboration. Thank you very much for these insights. I wish you well and say goodbye. Thanks a lot.
Thank you from me.
And I think there are similarities with our next talk, taking an idea or a technology that is very promising in its ability to save our planet and working with companies worldwide to leverage it and make the technology grow. Christine, tell us who is our next guest and what will you be talking about?
Our next guest is a colleague and he's an expert when it comes to hydrogen. I'll be talking with him about the promising future in hydrogen industry. Give a warm welcome to Bernd Kalusche. Hi Bernd, great having you here. Let's take a seat.
Thanks for having me.
Sure. Bernd, you are the head of oil and gas and hydrogen, the vertical. And the last one, hydrogen, is in all ears as sustainability and CO2 reduction is getting more and more important. What is the Siemens view on hydrogen?
Well, although hydrogen is not the answer of all the world's problems, probably, it will play a key role in the energy transition to decarbonize the industry and energy sector, and also to some extent the transportation sector. We at Siemens look at the entire value chain from production, conversion, distribution to usage.
So when thinking of Siemens and hydrogen, many people think about the Silyzer from Siemens Energy. Can you shed some light on this and explain the difference between Siemens AG and Siemens Energy?
Yes, in fact, there is some confusion in the market about what Siemens Energy is doing and what Siemens is doing. And in fact, we are very clear in our message. We are two separate companies, which is a fact. And Siemens Energy focuses on the power generation and the production of hydrogen by means of electrolyzers, whereas we as Siemens AG provide everything to our customers to plan, automate, operate, digitalize production plants for hydrogen, for ammonia, for methanol, but that's not everything. Also the infrastructure that comes along with it, like pipelines, tank terminals, and storage.
So it sounds like, as you talk about it, that the hydrogen economy is just like every other process industry?
Yes and no. The production of hydrogen is a chemical process performed in a chemical plant. That's about right. And we as Siemens have a lot of expertise around the world to help our customers building and efficiently operating chemical plants along with all the relevant safety aspects. On the other hand, if you look at the hydrogen economy that is now about to start developing, we are talking about modular plants, scalable plants, often in remote locations, being remotely operated. And we are talking about a completely new infrastructure that is being built along with it.
So what kind of customers does Siemens serve?
Actually, we are a partner for all protagonists along the value chain. And that starts with the technology provider. That means the package unit builders or process OEMs, as you may want to call them, building electrolyzers or carbon capture units or reactors. And those customers need everything from rectifiers, sensors, actuators, motors, up to the automation layer. And then we have the planners and EPCs. They require total solutions from power distribution to the automation solution. And last but not least, we have the investor being interested in a safe and efficient operation of the entire plant. We need to make sure that these interests are also covered. And all these groups need modern software to efficiently plan the entire plant.
So that's a big list we can provide.
Absolutely. That's the good thing. We can cover all the electrification, automation, digitalization needs, and even more if there is a funding need. Siemens Financial Services is there to support.
So what makes Siemens special in that approach?
Well, First of all, it's the great bandwidth of our portfolio, which we provide on a global base along with our industry expertise. But if you think again of the characteristics of the new hydrogen economy that is about to being built, we talk about modular, scalable plants, remotely operated, sometimes connected to the cloud. And that's exactly what our products are being designed for, made for, and certified for.
This all sounds fantastic as you describe it. Can you give us an example where Siemens technology has supported customers on their way to decarbonize?
Sure. If we look at Germany, everyone currently talks about Wunsiedel, a green hydrogen production plant where basically everything has been supplied from Siemens, from the power distribution to the control system. And via the MindSphere cloud, everything is connected with each other with the power generation and with the power storage.
And for those who are interested in learning more about our project in Wunsiedel, there is a great video available on Amazon Prime. It's called Alles auf Grün, Wunsiedel. And it's available, of course, with English subtitles. But Bernd, this is not the only project we have fulfilled with hydrogen. There is much more, I guess.
Yeah, of course, there's a lot in the pipeline currently. The boom has started to pick up. And we are involved in refineries, in steel plants, in production of sustainable food plants, and so on. And we do not do every project by ourselves. We have a great network of partners, and many of these projects are also being taken care of by our partners.
That was a lot of information. What would be your closing statement to sum up the most important points?
Yeah, I think it's evident the hydrogen boom is about to start or has started, but it will rather be a marathon at high pace, not a sprint. Also, we see different approaches across the regions. Some regions are focusing more on blue hydrogen, like Northern America. Some are more into green hydrogen, like Europe and Australia.
Can you explain the difference between blue and green hydrogen?
Yeah, sure. Blue hydrogen is made in the traditional way from natural gas, and the CO2 is taken out by carbon capture. And green hydrogen is made with water electrolyzers, utilizing green power from wind or solar.
Okay, yeah. But both are very sustainable.
Both are sustainable, green a little bit more than blue. Yeah, and of course there are differences in price, and this is why blue could be an intermediate until we reach the level where everything is green. And this is also why in Asia or the Middle East we see a mixture of both.
Mm-hmm. Okay.
Yeah. Also, plant sizes are currently increasing rapidly. So we started with pilot plants, and now we are already in the gigawatt scale in some regions. Wow. So the market is really picking up right now. And the good thing, we as Siemens, we are happy and we are proud to be part of it and serve our customers along the value chain, may it be technology providers, process OEMs, EPCs, and investors with our hydrogen-enabled portfolio of electrification, automation, digitalization, along with all the services customers need.
It definitely all sounds great, Bernd, what your treasure box has to offer, providing solutions for our customers. Thank you so much for explaining and sharing your insights. I'm pretty sure we will talk more about the hydrogen topic in the further events to come. And with this, we are already at the end of this Siemens and Guest session. Andy, why don't you come over and join me for our last round on the sofa?
Thanks, Christine. Yes, and after all those talks, we can really say that the chemical industry is experiencing a digital and an ecological transformation. Enormous potential for a sustainable future.
And if you want to find out more about the potential for your company, don't hesitate to contact us. Let's create the future together.
We're looking forward to it. Talk soon. Bye-bye.
Bye-bye.